Hi students, let's look at this question here, which is on the application of integration. Let's see how I can do this proficiently. This question was taken from the year 2011 CJC P1 Q8. So the diagram below shows the curve with equation yx squared minus 1 tangent of this. That's pretty okay. And the curve to the curve at the point 1, 0. Okay, great. So write down the coordinates of the point where the tangent meets x equals to 3. So the coordinates of the point where the tangent meets the line x equals to 3. I think just write down. It shouldn't be too big of a problem. So the first one is when x equals to 3. Just sub into the equation of the tangent, which is actually y equals to 2x minus 2. This is y equals to x squared minus 1. So that will be just 2 times 3 minus 2. Right? That would just be 6 minus 2, which is 4. So the coordinates 3, 4. Right? That's all. Then after which the region R is shaded by the diagram. It is bounded by the curve, this curve here. And after which tangent to the 1, 0, which is this one, and also x equals to 3. So this is the region R. Find the area of R. So I think this is not too bad. You basically just need to find this integral here minus of this triangle, this what do you call it, this triangle here. So this, we already found this area here. I mean, this point here is 3, 4. So this is 3 and 4. Okay, this will just be 3 and 8. Right, but you don't really need that. What you can do is actually for 2 area of R will just be the integral of 1 to 3, the curve itself, 2 square minus 1 dx, minus of the triangle, this triangle here. So this is half times base, which is 2 units, times height, which is 4. So times 2 times 4, that will be 4 units. So half times base times height. Alright, so this case here, once done, we'll get x cubed over 3 minus x. This is 3 minus 4. And what we get is actually just 3 cubed over 3 minus 3 minus 1/3 minus 1 minus 4. Then in calculator, what we're going to get is just very quickly 9 minus 3 minus negative 2/3. That will be 8 over 3. Okay, it's 8 over 3 square units. That's how you do. I think the second part is quite fast. Let's look at the last one, which is finding the exact volume of revolution of R through 2 pi about the y-axis. So you need this axis here. So you're just gonna rotate this over here. We need the volume like that. Okay, this is the volume here. When you rotate it, it looks something like that. Okay, you need to minus off this side, so it's something like that. If you can. Okay, so it may look very complicated. So let me just model this out for you. So I've shaded the area R here. So I'm gonna just revolve this around the y-axis. So you must be able to visualize it in exam. So this is it. We'll revolve around this. So let's see how we can revolve this. There you go. Okay, it looks something like that over here. Visualizing it is like that. Okay, so how we do it? So essentially, you can see that there are two. The outer layer, you have this bottom dome, this bottom cut cone here. Then this is a cylinder. You see this cylinder here? Okay, so that's why it's all the more difficult to visualize this part here. So let me explain. What we need is actually taking the outer layer and minus of the inner. The inner layer, this volume is quite okay. So this smooth curve inside here is easy to generate, right? It's essentially rotating about this around it. Okay, so let me just visualize this for you. Just write it down. I'll try to draw. So the required volume Okay, first of all, we need the cylinder on top. So I just draw it up. The cylinder on top will be like something like that. Just draw this out like that. Okay, and after which we need the curve like that. This is okay. And after which this outer layer here. This outer layer should be fine, I feel. Not like it's hard to find, right? Then what we need to is minus off the inner layer of that portion, which is this curve in the middle. This curve here. Okay, I hope you can visualize that. So there's this curve in the middle that you need to minus off. Alright, so the cylinder, we'll just deal with the cylinder first. The cylinder here is actually just this portion here, right? So you're looking at this portion here, which is actually the height here will be 4 units. And then the radius will be 3. This is 3 units, right? Okay, this is radius. So this is 8 minus 4. So the cylinder up here will be pi r squared times 4. Alright, so that is a cylinder. Whereas this bottom one here, what we could do is actually just integrate this area here. Okay, so this integrate, this would just be the volume here would just be integral of 0 to 4 here. Right, dy, huh? So 0 to 4 pi x square dy, and this x square should be the x of the tangent. So I'm going to let this be 1 and this is 2. Okay, so this should be x2, the tangent equation there. So just make sure you understand what is this going on here. So this will be the tangent equation will then be x, because it's x, right? X squared is what we need, so it's y2 plus 2 over 2 equals x squared. So I'm going to use that. So this would be pi, for this case is pi 3 squared to the power 4 plus pi 0 to 4, x squared would just be y plus 2 over 2, so it's y plus 2 over 2, this is y2, okay? So this is square dy. Now then the subsequent one, this should be quite fast, this in the middle here. So now what I did was I just find the volume of the, without the minus of the bottom, right? So this cylinder here, the top cylinder here, and this bottom one here, that's what we found. Now I'm going to find the area of the one that I need the minus, which is the one inside here. And the one inside here, you will start with 0 and end with 8 here. So that's okay, this is 8, right? So 0 is here, and this is 8. Okay, so this will just be integral of pi 0 to 8, and what we need is actually x1 square dy, because this is with respect, you revolve about y, so this is x dy. So this will be 0 to 8 dy. So we're gonna find this as y1 plus 1 plus x1 square. Okay, so this case here, what we get is x1 square y1 plus 1. Okay, good. So this is pi 0.8 y1 plus 1. So this is just y plus 1. So this is surprisingly easy to find. What is maybe more, actually it's not that difficult also, so it's okay. So this will be, because of exact value, so just make sure you just key this without keying the pi. So 9 times 4 will just be 36 pi. Okay, plus this would be pi. This is pretty okay also, so I think I'm just gonna say 1 over 4 y squared plus 4y plus 4 dy, and after which we're gonna just put this as pi. So I can just integrate this straight. y squared over 2 plus y, 8, 0. Okay, 8, 0, 0 to 8. Yep, then what I'll need next is actually just integrating, so it's not too bad. So this 1/4 can bring it up. Plus y squared over 2, then it will be 4y minus pi. Okay, this will be 8 square over 2 plus 8 will be 40. Alright, then we're just gonna look at the subsequent one, which is 0 to 4 here. 0 to 4 will be plus pi over 4. So this will be solve this as 4 is 208 over 3 minus 0, which is 0. Okay, 40 pi. Then we get 36. 36 plus 280. This will be 40 over 3 pi cube units. Okay, so that's how we do this question here proficiently. If you have any questions or comments at all, please let me know, and I will see you in the next question.